Okay, this is the homework helper for 7-4 in the workbook, polygons. Okay, let's start with the top part there in 1 through 6. The directions for 1 through 6 ask you to find the sum of the angle measures in each figure. Now this should not actually be that hard because you should actually have a lot of these angle figures in your notes. But I will repeat what you've seen in your notes, and that is that there is a basic formula that is derived from the process of triangulation that can help us find the sum of the angles in any figure, and that formula is n minus 2 times 180, where n is the number of sides of the shape. We change n into the number of sides, use the order of operations, and we'll find the sum of the angle measures. So if we look at number 1, for instance, number 1 has 4 sides. So I'm going to go in the formula and change that into 4 minus 2 times 180 to find the sum of the angle measures. Now again, you have to make sure you use the order of operations here. So I'm going to do 4 minus 2 first because it's in the parentheses, which is 2. 2 times 180 is 360 degrees. When we take a look at question 4 right beneath it, we can use the exact same formula even though it's a different shape. That will basically work for every two-dimensional figure other than a circle, and of course it doesn't work for a circle because a circle doesn't really have any sides, and so you couldn't change n into the number of sides because there isn't any. So here, 3 sides in a triangle, so 3 minus 2 times 180. That's going to be the same as 1 times 180 when we use the order of operations, or 180 degrees. Remember, that formula is based off the concept of triangulation. Triangulation is when we chop a shape into triangles, and then since we know the sum of the angles of a triangle is 180 degrees, we just take the number of triangles that are formed and multiply that by 180 to find the sum of the angles. If we were looking at something like question number 5, for instance, and I asked you to triangulate it, what you do when you triangulate is you pick a corner and draw a line to all the other corners. Some of those, of course, are already there, but some of them are not, and you're going to draw the ones that are not in this case. And as I draw those in, you can see in this shape I end up with 5 triangles. 5 times 180 would then give me my answer. If you want to go back and see some proof of that, go back and look at question 1, to which we already know the answer. Triangulate it. Pick a corner and draw a line to all the other corners. Well, as you can see, there's only one corner in which there is not already a line. Notice when I draw that line, I create 2 triangles. A triangle is 180, so 2 times 180, which is exactly what I did in the formula, gives me 360 degrees. Now, the next set of questions is also going to rely on that formula. However, what they're asking is different. They're asking you to find the angle measures in the regular polygon. Remember, what regular implies is that all the sides are the same and all the angles are the same. So once we know what all the angles add up to, all we have to do is divide by how many angles there are, and that'll tell us what just one angle is, which is what they're asking for in this particular question. Particular question set, rather. So here we can use the n minus 2 times 180. Again, we see 6 sides in question number 7. So 6 minus 2 times 180. That's the same as 4 times 180. Remember, I'm using the order of operations, or 720 degrees. That is not my final answer, though, because that's all the angles. Again, they just want one angle. Well, if we look, we have 1, 2, 3, 4, 5, 6 angles. So I'm going to take that 720 now and divide it by 6. And when I take that 720 and divide by 6, I end up with, in this case, 120 degrees. So each angle here is going to be 120 degrees. We'll also take a look at question 8, but 8 is one you should really know the answer to. And the reason you should know the answer to it is because that shape does kind of look like a square. Even if it wasn't a square, we would assume that that's a rectangle then. Squares and rectangles have one property in common, and that's what the measures of the angles are. That's the fact that the angles are all 90 degrees. Now the fact that we can say that this is a square for sure is because the directions say that this is a regular polygon. Remember what that means is that all four sides have to be exactly the same. Well, a rectangle proper doesn't necessarily have that, but a square would. A square is forced to have four sides that are the same. A rectangle does not necessarily have to have that, but it could. But regardless, it would be 90-degree angles all the way around. If you want to check it, you can. It would be the exact same formula that we did up here in question number 1 because it has four sides. 4 minus 2 times 180, which is going to change into 360. And then we're dividing it by the four angles in the shape, and that's how I come up with my 90 degrees. Okay, let's go ahead and take a look at the bottom part here. In questions 13 through 15 now, they're asking me to give all the names that apply to the figure. So which names, and there could be more than one answer, which is why there's multiple blanks there, apply to the shape here. Let's take a look at one very specific one, question number 15 here. In question number 15, first off, we do see that that would be a quadrilateral. And the reason we know that's a quadrilateral is because it has four sides. Any quadrilateral has to have four sides. Notice that 13 and 14 would also be quadrilaterals, but they want us to get a little more specific than that. They want us to say which type of quadrilateral this is, and that's where we'll go here. From the term of quadrilateral, we can see what's different about question 15 than a lot of the quadrilaterals you've seen today is that this one only has one set of parallel sides. A lot of the quadrilaterals, the rectangle, the square, the rhombus, and so on, have two sets of parallel sides. When we have just one, that's going to be a trapezoid. And indeed, this is a very specific type of trapezoid, so we have one additional name because these two sides that look the same indeed are, and that's the term isosceles. Remember, just like a triangle, isosceles implies that two sides are congruent. We have indeed an isosceles trapezoid here that implies that it's a trapezoid with one set of sides that are exactly the same. You'll do all the same naming techniques in question 13 and 14, realizing that there could be more than one acceptable answer.